So good morning. Today is September 25th, and I want to show you how water can change many states. So what we have here is we have a burner, a hot plate, okay, with two burners, and I've already got it heating up. This is a foil pan, and this is a glass beaker. So first, I want to pour in water, just ordinary water, into the glass beaker, and we're gonna add some salt. Maybe it's all stuck together. Hold on. Okay. Some salt out it. Whoa, that's a lot of salt. And then we'll stir it up. And mix it up, mix it up, mix it up. Okay, real quick question for you. What temperature does the water have to be to start boiling? 100 degrees Celsius. Very good. All right, in this next pan, we're going to talk about how this is going to take a while to happen. But we're going to talk about how water can take many shapes depending on the temperature. So I have an ice tray with ice cubes. See? And we'll put a couple of cubes of ice in the pan. And you should start to see it melting already. I'm just going to use this spoon. Yeah. So do you remember whenever we took the ice cubes out and put them in the pan, what is the temperature that the water must be to start melting? 0 degrees Celsius. Very good. Okay, I hear noise coming out of this speaker. So no one ever said this experiment was a quick experiment. For today's purposes, I'm going to let you watch the video in whole so you can see the time it takes, but I might edit it and speed it up some. Now, while we're waiting, what do you think this ice in this pan is going to do when it's all melted if I keep it on the heat? Do you see? Can you see that? Can you see what's happening? There's vapors coming off. What are those vapors, guys? What is that? Evaporation. Look, that little water is bubbling right there. Can you see it? That ice cube's losing its shape. It's physical. Look, the ice cube's physical properties are changing. Interesting how if you stir stuff up, it stops boiling. All right, I'll leave it alone. This one's got my salt water. Come on, salt water. What should we find left behind? If this glass beaker boils and all this water evaporates, what should happen to the salt? Yeah, it'll be left behind. So we'll see if that actually happens. see the water boiling. I'm just going to adjust my camera here. I don't want my putty to get cooked. I wish you could see it here, but you can't really see the steam coming up. The steam. Isn't that what we call it at home? Steam. The evaporation process. It's really hard to see it right now. But trust me, put my hand here. It's hot. It's hot. You starting to see bubbles in this one, guys? Yeah, tiny bubbles. Okay, so sharpen the pencils for today. And let's see what happened. Oh, wow. All my water is almost evaporated from this entire container. Ooh. I should be using safety equipment right now, which I'm totally not. But look, there's not that much water left. Barely any water left. That's it. Let's get it going. Evaporate away. This one, little guy, oh, he's just bubbling away. Just bubbling away. This is like the last bit of the water from the ice cubes. Pretty cool. I don't know if you can see it, but what's going on the side here? Right there. What is that called? Condensation. Yay! You're so smart. This is all the water that's left in this pan, guys. Right there. That's it. Everything else is dry. How hot is this? Not hot at all. Look. Oh. That was it. That's all the water left. 2 ice cubes completely disappeared into thin air. Literally. Alright. That's that one. I'm going to pause this video for now and just let this keep going. And we'll come back and check it in a little bit. Some time has passed since we boiled the water, and I wanted to show you, I'm going to turn this off real quick. I wanted to show you what was left in the beaker. All that's left in there is all that salt I poured in there. All that water has evaporated. See? And now all that's left And now all that's left is the salt. Okay, and I'll pass this around later in class and show you. All right.
Bye.
Bye. Swear to God.